Can you hear me? Great. So my name is Darius, and today I want to talk about the dawn of the enterprise AR cloud, and especially on how visual mapping and positioning will transform augmented reality from a nice-to-have feature, as you just said, to a must-have. So just a little bit about myself. I am the CEO of this company called Visualix. We are a computer vision company based in Berlin. We are 15 people, and we specialize on the visual mapping and positioning recorded from mobile devices. So you can take a mobile device, you can scan an entire venue, a large scale, logistics hall, production hall, retail building, and then you can localize your phone within the building with centimeter precision. And this has many applications. One of them is augmented reality. So if you look at enterprise augmented reality today, you kind of have two tracks, right? You have the object-based AR, meaning a kind of local reference of, let's say, an object you have in front of you. You can track it with 3D, CAD-based tracking, let's say, and it always kind of comes with the object, right? You move the object, AR moves with it. And this has a lot of use cases, for example, in industrial AR, etc. So this is cool. On the other hand, we have spatial AR. With spatial AR, I mean AR that is not tied to objects, but is actually tied to coordinates in space itself. So I could place augmented reality exactly here. I could place it exactly here. And this is independent of the objects in the building that I can move around. They still are persistent and stay. So let's talk a little bit about the benefits of spatial AR. If you really want to create shared experiences visible from multiple phones, you actually need centimeter precise placement of AR in a space in order for you to have shared experiences on multiple mobiles for training sessions and many other things that you can do, for example, gaming. Indoor navigation is, of course, a very big topic, and this has to be solved at scale as well. And for this, you need not only centimeter precise placement, but also very precise orientation to solve this problem. Augmented assistance, also very interesting for retail too. So the ways you achieve spatial AR today are quite limited and a little bit old school, in my opinion. You can use GPS and beacon to localize yourself in a large production facility, fine. But GPS and beacons always have the problem of being not 100% accurate. They are 3 meter inaccurate, maybe 1 meter. If you go down to ultra wideband, you can go even down to 10, 20 centimeter, but there you have no orientation aspect whatsoever in this. So this is not usable for AR. Marker-based tracking, that's really a little bit better, but the problem with markers are that you have to place them, you have to measure them with a laser, and this is a lot of manual work that really, really needs a lot of manual input. So on the other hand, you have new technologies like ARKit. ARKit is really nice. You can sync up two devices, but the only problem with that is that it's very locally defined. Well, there are many problems, but you can locally, for example, have a table with some features on here. You can sync two phones, and you can see the same objects. But this is totally not applicable to a large-scale industrial facility where you don't have 2 square meters, but you have 200,000. So that's not usable as well. Also, ARKit doesn't work at large distances. If I'm in a factory setting, as I'm now, let's say, and I want to localize myself only with my phone, with my visual input, this doesn't work because the distance to the walls are 10 meters away. So this is not applicable. So the challenge of spatial AR is really the spatial accuracy at scale. So we thought about how can we solve this problem? And we came up with a very interesting computer vision approach. And is there a slide missing? Okay. Right. So, and in order to suffice the requirements, basically, of AR, we need, number one, it works in large spaces. It works with centimeter precision. Those are the two basic requirements. And we solve this by combining technologies. We use ARKit and AR Core on the mobile, but we have a very, very heavy computational system on the back end that analyzes the data you get from the phone and translates it into a very robust and large AR cloud that can retain its accuracy even 100 meters away. Like if you map a space, let's say 100 times 100 meters, it still is accurate. On the backend side, we do a lot of optimization, loop closure, bundle adjustments, stuff like that really make the map really centimeter precise at scale. We offer an end-to-end solution for this. So to really use AR, you need all 3 steps. You need all the value chain. You need the mapping, scanning part. you need the content to be deployed on the virtual 3D map that you have. And second of all, you need then the viewing experience, a viewing SDK that you can just open in your building, and you can right away see the AR you placed at scale. So basically exactly how you imagine it for movies, you basically can do with our technology. So I can show you a few demonstrations of this. If we can play number 1 video for a few seconds, just to give you an impression of how mapping actually works. So on the mapping side, you just start, we compute the points basically based on like certain contrast rules. We know, okay, you move with your phone 50 centimeter, pixel-wise it's shifted, let's say, by 5 pixels, so we know exactly the distance. And this is computationally very heavy, that we can do not only locally in an environment like this, but also on very large-scale structures, such as houses outside. Okay, we can switch to the next video, to number 3. So, and this is the third step. I already placed augmented content somewhere, and now we have 2 people, me and Henry, standing in a building, and we can see basically the same object from 2 different perspectives. So here you see an augmented version of my co-founder, Michael, and Henry and I see him centimeter precisely placed in a room. Yeah. In real life, he looks like that as well. He doesn't emote much. He's our CTO. No, I'm kidding. He's a cool guy. Okay, and the accuracy you can actually see in a few seconds. As you can see, we have red augmented arrows placed on the floor. And you can get an inkling of the accuracy in 1 frame where I'm pointing with my finger on a certain arrow. You can check it out about now. And if you pause it, you can see that the accuracy is upheld by about 2 centimeters. So we solved this problem of large-scale spatial AR. So we can go back to the presentation. So, so basically, the vision of our company is to be the first enterprise AR cloud. In the consumer space, there are already a lot of companies in the States currently doing this. You have 6D, you have Ubiquity 6, who are very consumer-focused. But the issue with that is it's not really tailored to enterprise, right? So we want to be this first enterprise AR cloud that enables one visual coordinate system where all seeing devices can visually log in and basically do a bunch of stuff, not only AR, but also asset tracking as well. So we want to be kind of the eye, the all-seeing eye in a factory to optimize a lot of processes at scale. And that's it for now. Does anybody have questions?